Okay, so it looks like a diamond, at least to me it does, right? Because it's kind of short. And the sides look even, so it can't be a trapezoid because this one has more than one parallel side. So that's one parallel side, and this is another parallel side. A kite, well, one of these sections isn't long and stuff. It looks like they bisect each other, so it can't be a kite. Triangle obviously can't be. A parallelogram. It could be a parallelogram because we have all the sides that are parallel to each other. Could be, but this one is definitely going to be a rhombus. Now, with this rhombus right over here, our formula is going to be 1/2 diagonal 1 times diagonal 2. Now, this 4, this represents the whole diagonal, so D1 is 4, right? If I'm trying to find D2, well, the thing is we don't know what D2 is. It didn't tell us, right? So we have to figure that out. We have to figure out what D2 actually is. So the thing over here, if we want to find out what these guys are, we need to first break this in half. So half of 4, it's going to be 2. So we have 2, and then we have 2, right? And then over here, we notice that this side is 6. So if this side is 6, this other side would be 6, that other side will be 6, and this other side will be 6. And then we also know we have right angles, right? So the thing about geometry is that topics that you learn from the past, they come back to haunt you. So this one, I'm going to use what I know about right triangles to find my missing sides. Now, let me just take one of these sections of triangles and draw it out. So let's use this. Okay, so I have a right triangle. Ugh, looks weird. This one is 2. This one is 6. And I'm trying to find out what that other this side of the triangle is, right? So lucky for me, I can use my Pythagorean theorem. I can use a squared plus b squared is equal to c squared, right? So this, I can just go ahead and replace it. My legs, A and B, they're going to be the shorter side. So one of them I don't know. Let's make that X. B I know. C, I don't. C is 6. And there you go. I'm going to start by solving for X by first taking the exponents. So I have X squared, I can't really solve that. 2 squared, that's 4. 6 squared, that's 36. Oops. And then we want to isolate X squared. X squared is equal to 40. And if I want to get, if I want to go ahead and get this square, the square out of the way, I'm going to square root both sides. Once I square root both sides, your x is by itself. You have a square root of 40, which you can break up as the square root of 4 and the square root of 10. And this over here, the square root of 4, that's a perfect square, so we can make it into 2 square root 10 if we want to be simplified. So now we just found out what our, so with this, I found out what one of these sections is, but I want to find out what the whole diagonal is. So if we're trying to find diagonal 2, we're going to add this one twice. So we're going to do 2 square root of 10 plus 2 square root of 10. And that's going to give me 4 square root of 10. So if I want to go ahead and find my area, I'm going to plug in my 4 and my 4 square root of 10. And I can go ahead and multiply. So you have 1/2 16 square root of 10, half of 16, that's 8 square root of 10. And this one is going to be in meters squared. Yeah, it's a lot of work, but it came through at the end, and that's my area. All right, cool. So that was one example. But let's say let's say instead of having this, we had a rhombus. Ugh. Where we knew our diagonals. So let's say this diagonal is 8 inches, and this whole diagonal, this is 9 inches. So again, we would use the same formula, 1/2 d1 times d2. And we'd multiply 8 times 9. 8 times 9, I think, is that 72? 8 times 9? Yep. So you're doing 1/2 72. Half of 72 is 36. So that's how this problem would be if they gave you all the diagonals. All right, let's look at our final example. Okay, let's look at this. We have another rhombus, but look, they gave us even less. They're trying to make our lives easier. All right, so I already know it's a rhombus. And I know the formula. It's 1/2 d1 times d2. And now I need to find what my first diagonal and what's my second diagonal. So here, you can just go ahead and draw it. So I just draw one of my diagonals over here. Now this 10, it's telling me that the black diagonal, the whole thing, it's 10. So I need to break that up, because breaking it up will help me find the other diagonal. Okay. So what's half? So I know that these diagonals bisect each other. They cut each other in half. So half of 10, that's 5. So this will be 5, and that will be 5. And I have right angles. And if this whole thing is 8, this will be 8, this will be 8, and this will be 8. So you see how I'm using the definitions to also help me out? So that's something to keep in mind. All right, so let me just redraw one of these portions of the triangle. So I have a right triangle. My right angle's here. This is 8. Looks like the bottom is 5. And I don't know what this is. That's the part of the diagonal I'm trying to find. So again, I'm going to use my Pythagorean theorem. A squared plus b squared is equal to c squared. And with this one, I'm going to replace everything. I don't know what one of my legs are, but I know one of them is 5, and I know my hypotenuse is 8. So now we have that x squared plus 25 is equal to 64. I just need to subtract both sides by 25. X squared, let's get my calculator. 6 is 25, 39. So I have an x squared and it's equal to 39. And if I want to get x by itself, I need to square root both sides. So this will just give me the square root of 39. Now 39, you can't really break it up. It'll just be 1 and 39, and it'll just give me the same square root thing. So I'm going to leave it like that. So I found one of the sides over here. It's a square root of 39. And if this side is a square root of 39, this other side will be the square root of 39. So to find D2, I need to do the square root of 39 plus the square root of 39, which is just 2 square root 39. All right, so now that I have everything, I can start plugging things in. So I have my 1/2. D1 was 10. D2 was 2 square root 39. 1/2 times 20 square root of 39. And half of 20 is 10 square root 39. Okay. Oh, and I need to put in my inches squared. So inches squared. There you go. So at the end, I got my area. It's 10 square root 39. All right. So that was just a recap of how to use all these different formulas. Like I said, if there's something you didn't understand in the video, just pause it and rewatch it again. And you're going to be using this video to help you with the problems I assigned for today. Okay? All right. See you on Wednesday.